Hello everyone. The next question we are going to solve is word break. Okay, let's see. It's given a string s and a dictionary verdict. S is a string and verdict is a dictionary. We have to return true if S can be segmented into space separated sequence of one or more dictionary words. Okay, is that? Oh, yeah, here. So let's take an example. So S can be segmented, like lead code can be broken into some words which are already in word dict, such as lead and code. Okay, so and apple, pen, and apple. So apple, pen, and apple. Another one is cats and dogs. So cats is there and is there. Okay, cat is not there. Cat, sand, and dog. Oh, so dog is not there. I mean, og is not there. If cat sand is there, then cat. Okay, cats. Yeah. So we can't represent it because somehow we will whether we will take sand or and, but we don't have this OG anywhere. So and length is this and 300 and 1000. What we can do is for A, let's check all A's. Okay, inside inside this verdict. So we found that apple is starting from A. Okay, and nothing else. Okay, let's take this example. This is better to understand. It will make us clear about everything. So cats and dog. So cats is inside two place. Cats or cat. And if we weren't able to find any word starting from C, then we will break our loop and say that it is false. Okay, we will return false. Else, we found cats. We check whether cats is in here. Yeah, it is in here. Whether cat is in here. Yeah, it is in here. Then call the rest on the function on the same word break, and we can use the same word twice. Okay, so it is a just recursive call. So what we're gonna do, check or word break. Yeah, check it. Check function we will call, and we will start from I, initially I, and and initially I. Yeah, only I is needed. Okay, if not if, so we will traverse verdict, traverse verdict, check for, like, if C is there, check for cats and cat. If it is already there, then move our pointer to this J. Okay, and then call it on the rest of the function. And if here there will be a base case that if J this I exceeded like a limit, then break it and return false. Else if it went to the, it will become length of S, then return true. Okay, so let's code it. It's an easy question if you know how recursion works. So let's take a function, take it, and we have a string A, and we also have our ith index. So initially I is equal to 0 if we haven't defined our I, and this S is equal to S. Okay, let's take it as S. While we can also use non-local, but let's take it as S. So while, not while, for I, not I, sorry, for idx in range, let's take it as start. It will be a better name. Start in range start, for I in range start. I in range start. No, no, sorry. For I in range, for I in verdict rather, verdict. Okay. If for word in verdict, that would be a better name. If S of start, okay, is equal to word of, can verdict having, no, verdict length is 1. The verdict, and each of the word inside verdict is also greater than 1. So if this is equal, if s of start is equal to word of 0, okay, equal to word 0, then what we have to do is check this the whole function on pass s and convert our s. If this is equal, we are starting from start. Okay, we have to do one more thing, like if length of our word, this word, length of word minus start is greater than length of word, this word minus start is greater than, yeah, we have to check whether the word we are taking, its length is uh, it's the word we are taking, whether its length is less than required length or greater than required length. So if it is greater, then we are gonna, like, we don't need this case. The length of word minus start is greater than length of, why are we doing start, sorry, length of word minus length of word is greater than length of our s minus start. Okay, if this is the case, then continue. We don't need you, don't need, we can't use this word to get our solution. Okay, and one more thing, or if this word, this word is not equal to s from start to start plus length of word, okay, of word, and continue, else call this function on start plus uh, length of word, yeah. Okay, now this should work. And if at any time, yeah, okay, so let's take a flag, found or not, okay. So found flag will be there, it is initially false. And if any word will be found if a word is matching, if the current index can have a possible solution, then found will become true. Okay, and if it is not possible, if not found, then return false at any instance. If not found, then return false. Okay, and one more thing we have to do, we have to check the base case. Like the base case will be when start will become length of s. So if start is equal to length of s, then return false, or return true, sorry, return true. And one more thing, can s be, yeah, so okay, now it should work. Let's return our function, return, check it, check it, given start s, given s, yeah. Let's check and debug our function. Giving false. So for word in verdict, if length of word is greater than length of s minus start, or word is not equal to S of start to start plus length of word, then continue. Else found is equal to true. Check. Okay. So, okay, sorry, I am doing one thing wrong. So if result is equal to, let's take result is equal to false. Initially, our, like, we won't be able to found it. Okay. Instead of doing found is equal to true, what we can do is, okay, instead of doing found is equal to true, like if here we have false, it will be also giving us now whether found is equal to true or not. So found is equal to this. Okay, found or, not this, found or, check it. Okay, found or, this time we are, this will be correct. So if we are able to found it, then we'll do found or check it, check the rest one. Okay, and when we return true here, so if not found at the end, then return false. Okay, instead we can say return found. Yeah, this will be a more cleaner code. So what we are doing here is, we have initially found is equal to false. Okay, that we might not found it. Okay, then we search for our word. If it is in there, if it is not in there, we don't update found and it will return our false. Okay, and if it is there, then it will check for all found. Okay, it will be like found or check it, and it will, this check it will only return true when start is equal to length of s. At any time it will reach at the end. So let's check it now. It got accepted, but let's check it on another test case to make sure. Will we, I guess it's quite simple to understand. All you have to write a clean code in here, like in this way. I just, you have to check each index, and if any of the index match, you can check the whole word, and if it is matching, then just return it. So let's try to submit it and see whether it is working or not. Yeah, see, I have submitted it 6 months back, so that's why it is easy for me to think about over it. But writing code is another part. Yeah, TLE, see, TLE is coming in here. So to solve this TLE, what we can do, we will check. Okay, this TLE, yeah, all are A's, and the end it is B. Okay, if 5 out of 42 so how it happened, how it got accepted? Let's check. Everything is A, so we are calling it on A. Okay. This thing. So if there is a, if like see, what is our string, what is the string we have to do, I mean we have to found is this A, and at the end it is B, but inside the word there is no B, so we won't be able to ever find this string. So what we will do, we will check, we will make a set of set of characters, chars in, like let's say chars in our string here. Okay, let's take it as a set. Yeah, tool y, chars in set, and the another will be chars in verdict. Dict. So both are our set. Okay, now what we will do, we will check all the characters inside it should be in the second one. Okay, so to check it, all in this should be here. So okay, what we can do, if I am having a set AB and this is A, so this minus this should be, yeah, this minus this, the set in char str minus this should be null. Okay, we are going to do this. Verdict list, so let's append it also. So for I, like, char set is equal to set. Okay, 1 second. Let's like it like list of set, not list of set. Set of S, yeah, directly convert into set of S. And to convert this into set of S, what we can do is to convert a dictionary. We will traverse our dictionary for word in verdict. Chars in dict dot add um, dot add set of word, something like this. This will be a pretty time consuming, but let's do this, like it won't be a problem. So if chars in str, I don't know how to do minus, but still let's just simply subtract it. Okay, so chars in str minus chars in dictionary. If this is, then return false. Such that if this is true, then return false. And if it is an empty, then no problem. Let's go on. Okay, so I don't have to do this. Unhashable type set. Okay. So how can we add it? Set a set of this, set of, we do for I in word add I. We have to do it like this. Let's run it on this test case. Okay. So already 18 minutes. And now it is accepted. Okay, let's submit it also on the previous test case. Let's run it on this test case. We got submitted. Let's directly submit it now. It should work, like according to me it should work. It is taking time. Taking again TLE. Okay, if this TLE, the TLE for it. Okay, yeah, if there is a B, oh no, it should return true directly without thinking. If all A's are there, and there's no okay, there's B in mid. One more. Sorry. I have to add one more thing. Okay, if this length, okay, is greater than the max of this, then we won't be able to find our string, or we would be able to, like triple A is there, okay, we can use triple A. To solve this. Okay, what if I have found it? Like, if found at any instant, then return. If found, then return true. Something like this will help or not. Any instance, if we are able to find our solution, then directly return it. How did it got accepted last time? How did it get accepted? Oh, I was using DP last time. Oh man, that's the problem. I have only used recursion. I have to memorize it also. Because if we have already found true for an yeah for k in range I comma n answer, or this is this, or call it on next k plus 1. Okay, let's do our DP. Forgotten some basic thing. Have used DP at the starting of it, like if DP of I is there, then return. So instead of using array, let's use our collections. We don't need it. Our code is also not bad. One second. Uh, so now we can remove this too. Like I haven't added this previously, but it still worked. So we can remove this too. Comment it out for now. Collection put default key memo is our code memo. Default length of int no bool. So if start in memo in memo, then return memo of start, else the memo of start will become return found, and instead of found, yeah, let's convert here. Found is equal to, so why we have to use memoization? Because for some i's it is already calculated, so why to calculate it again? That's why we are using this. Now it will work flawlessly even after removing this part. See, let's submit it. So let's remove this part. This is what? Found is odd. Why this is not working on LeetCode? One second. If start in memo, return memo of start, and sorry, memo of start is equal to find. Sorry, memo of start is equal to found now. How did it work back there? Here 24 minutes is still long. Let's complete it within 1 minute. And the code. Okay, got submitted. Thank you guys. Subscribe for more questions. We will meet soon.